Hello and welcome you all. This question was asked in GATE 2021. Let's discuss it. The first part of solving any question is to read that question properly and note down all the given data. Here the question is, in an odometer apparatus, a specimen of fully saturated clay has been consolidated under a vertical pressure of 50 kN per meter square and is presently at equilibrium. The effective stress and pore water pressure immediately on increasing the vertical stress to 150 kN per meter square are. So here 4 options are given. We need to choose one option. So this question is from the topic of consolidation Terzaghi theory. Let's understand the theory first. Whenever any saturated soil is subjected to any vertical load, the total stress in the soil induces. Since it is known that total stress is taken by two components. The first component is carried by pore water, which is present in the continuous void and is called pore water pressure, and the remaining part of the stress is taken by the solid particle at their point of contact and is called effective stress. When any additional load is applied on the saturated soil, all the stresses are taken by pore water. It means at time t is equal to 0, that is instantaneously after applying the vertical load, all the loads are taken by the pore water. So at time t is equal to 0, U becomes the total stress. At time t is equal to 0, all the incremental load, all the vertical loads transfer to this pore water. That is, we can write at time t is equal to 0, U becomes the total stress and the effective stress is 0 at that time, as you can see in this figure also. At time t is equal to 0, the pore water pressure becomes the total stress at all the depth and the effective stress is 0. The reason behind that the clay has a very low permeability and water is incompressible as compared with the soil skeleton. Now, due to this pore water pressure, water in the voids, water presents in the voids start squeezing out and primary consolidation takes place. Due to the squeezing out of the pore water from the soil solids, the consolidation takes place and that is called primary consolidation. So here you can see in the figure, this figure you can see in this time, in the primary consolidation time, what happens? The pore water keeps decreasing. Why? Due to squeezing out of the pore water. So in this time, the pore water keeps decreasing and effective stress keeps increasing proportionally. So you can see in this figure, as this pore water decreases, proportionally effective stresses increases, and it will increase at the end of primary consolidation, and at that time the pore water becomes 0 and the effective stress becomes the total stress, and this time is called, we can say that soil is in equilibrium. However, after that equilibrium, consolidation also takes place, and that is called secondary consolidation, and that is due to the rearrangement of soil solids. So now our concern here is to find here the question. Our concern is to find the effective stress and pore water pressure immediately. Immediately means at time is equal to 0. So we know at time t is equal to 0, what happens? The effective stress, the pore water pressure becomes equal to the incremental stress. Whatever the extra stresses is applied on the soil, soil, the all the stresses transferred to the pore water at time t is equal to 0, that is instantaneously or immediately. So here it is asking immediately, it means we need to find at time t is equal to 0. What is the value of u? U will be equal to the additional stress, and here in the question additional stress is 150 minus 50, 150 kilonewton minus 50 kilonewton per meter square, that is 100 kilonewton per meter square. Okay, initially the soil was subjected to 50 kilonewton per meter square, and that soil is the stresses increases to 150, that is incremental load is 150 minus 50. So we can say the incremental vertical stress is 100 kilonewton per meter square. So immediately, that is at time t is equal to 0, the pore water becomes the 100 kilonewton per meter square. Now what will be the value of effective stress? So effective stress will be same as earlier, whatever the amount of stress is applied at equilibrium, that is the value of effective stress. So effective stress will be same as earlier, which is 50 kilonewton per meter square. Now check the option which will be now here. Now always be cautious with the terms. Here in this question it is asking effective stress and pore water pressure. So you need to check the answer accordingly. So effective stress is 50 and 100. So your answer will be 50 and 100. So option number B will be your right option. Thank you.